Hey everybody, it's Derek. Welcome to eApprentice Office Hours. So Mike is going to present Class 9 from our multi-axis course. This is where my mouse is around here, and actually the part that you see on the front page is the part we're going to do today. So Mike is going to show you, we're going to set this part up on a dovetail fixture and machine the part on a 5-axis CNC vertical milling machine. So I'd like to encourage you guys to go to the site, take a look through the courses, see if there's something you would like to take there. We start with beginning Mastercam. We have 4 Mastercam classes. We have the beginning class, we have the 3D class, which includes high-speed tool paths. We have the multi-axis class. Sorry, you'll get a taste of that today. Jay Kramer is also with us online. Jay has a 5-axis Mastercam class, and we also have a class in SolidWorks. Mike Witten will be joining us a little bit later today for the Q&A. So if you have questions, what I'd like you to do is type in the questions as we go along. You can also use the raise your hand function if it's something that you would like to jump in on in the middle of the presentation. Depending how this goes, sometimes I'll stop Micah and do that in the middle, or sometimes I'll just hold on until the end. So that's about it for now. I think we're ready to go, so I'm going to switch over to Micah. Are you there, Micah?
I am. Hey guys. So today, like Derek said, we'll be going over Assignment 9 from the multi-axis class. Assignment 9 is an 11-sided part that we'll be machining on a 5-axis vertical machining center fitted with a trunnion. Short-run parts like these allow 5-axis machining centers to really shine. If we tried to machine this on a vertical machining center without a trunnion, we'd have to make fixtures to hold the part at different angles and flip it 11 times to machine each side of the part. Using 5-axis machines and a dovetail fixture, which we'll get into a little later, the part can be made in just 3 operations. The first operation takes place in a standard mill to machine a dovetail into the end of the stock, which would be on this end. This is actually the bottom as it's imported. The second operation takes place in the 5-axis mill and machines 10 sides of the parts, as well as the holes through it. So it actually does the slot here, as you can see, and all 8 sides plus the top, which is on the bottom there. The third operation skims the dovetail off the bottom of the part and machines the holes in the bottom, which is this side here. Few operations means fewer chances for tolerances to slip and much greater productivity, since we can cut down on the number of times the machine has to stop for an operator to flip the part. We'll start by importing and placing our fixture geometry. Before we import and place we'll start by importing and placing our fixture geometry before we import and place our part geometry. Select File, File Merge Pattern. This function allows us to combine geometry from multiple files into a new file. Navigate to the fixture file, select it, click Open, and click OK to place the geometry. When programming on a trunnion setup, the intersection between the trunnion rotation axis and rotating table axis is the same as the world 0 in Mastercam, so all our geometry needs to be placed relative to that point. So the world 0 is here, where the 3 brown axes intersect, and the 2 rotation axes are the center point here, and then the center point of this rotating table here. So that intersection between those 2 rotational axes needs to be the same as these 3 brown axes. On the machine we'll be using, the top of the rotary table is ½ an inch below the intersection point. So we'll need to move the bottom of our fixture ½ an inch below the Mastercam World 0. First though, we'll need to create some wireframe geometry to attach points to manipulate the fixture. Open the Level Manager, name Levels 1 and 2, Fixture Geometry. and create a new level called Fixture Wireframe. Change the geometry creation color to something that contrasts with the fixture. Then select Create, Curve, Curve on all edges. Activate the Solid Selection tool, deselect the Face Selection tool, select both parts of the fixture, so it's actually got one half of the vise and then the rest of the fixture here, End Selection, and click OK. Select Transform, Translate, window around both halves of the fixture, and End Selection. Select the Move Radio button, then use the point-to-point method to move the geometry to the origin. So we'll select the center point, so we'll use the arc center override of the circle on the bottom, and then we'll go ahead and move it to the origin by using the auto cursor there. Select Quick Mask Result, then Transform, Translate, and move the part an additional ½ an inch in the Z direction. Now that we've imported and placed our fixture, and it's sitting at the right spot, we can import and place the part to machine. Select File, File Merge Pattern. Navigate to the part file, select it, click Open, and then click OK to place. The part geometry is also just a solid, and we need to move it to place it in the correct place on the fixture. So we'll need to add some wireframe geometry to make that possible. Open the Level Manager, create a new level called Part Wireframe, and then name the level of the part so that everything stays organized. We want to make sure the wireframe level is the active level. Select a geometry creation color that contrasts with the geometry on the screen, and select Create, Curve, Curve on all edges. Activate the Solid Selection tool, select the part, End Selection, and click OK. To move the part down to the fixture, but keep it centered within the fixture, let's create a couple of pieces of geometry to make that process easier. Open a Level Manager and create a new level called Construction Geometry. Sorry, my cat is in the background here. Create a line between the midpoints of the lines on the vise jaws. So go ahead and zoom in on this. And you can actually right-click on this Quick Mask Wireframe button over here, and then it'll only select wireframe geometry. So it can snap to the midpoint, and then sometimes it helps to spin it around just a little bit to snap to the other midpoint. Like that. Click the blue Apply button. And then we'll create another line on the base of the part. So again, Quick Mask Wireframe. And I'm actually right-clicking on the Quick Mask Wireframe, so only wireframe geometry is selectable. And then since that's being picky, we can use the midpoint override and then just click on the line to automatically select the midpoint there. And click OK. select Transform, Translate, Window around the part, and End Selection. We'll use the point-to-point method again. Picking the midpoint of each line is pretty tricky. So we'll use the midpoint override, and then right-click on the Quick Mask wireframe, and then select the line in the middle. So you can see it just barely highlight white. And then again here, we'll use the midpoint override, right-click on Quick Mask wireframe, and select the line to automatically snap to the midpoint. And click OK. Since we don't want the part sitting right at the top of the vise, let's quick mask the result. And I left-clicked to quick mask the result there. And translate it 1/4 inch in the Z direction. This will give us plenty of clearance between the tools and the vise. Now that we have our geometry placed, we can set up our machine definition. Select Machine Type, Mill, Manage List. There are two generic 5-axis machine definitions, here and here, but neither one is a trunnion style setup. So we'll go ahead and add the Haas VF-TR series 5x mill definition to our machine definition menu to use for this part. And I have actually already added it over here. So to add that, you can just click these buttons in the middle, and you can add and remove different machine definitions. Select Machine Type, Mill, and select the 5-axis machine definition we just added. Open the Level Manager and make the fixture and construction geometry levels invisible. Expand the machine properties and select Tool Settings. Enter a program number and set the other settings as needed. I'll be calculating feed rates from material, assigning tool numbers sequentially, using the tools Step, Peck, and Coolant, and selecting 6061 aluminum as the material. Click on Stock Setup, and then the bounding box button. Expand the stock 0.1 in the X and Y directions, and click OK. For the Z value, add in 1/4 inch for the distance from the bottom of the part to the fixture, and then an additional 80 thousandths for the dovetail to fit inside the fixture. So do a plus 0.08. Click OK to exit. Turn the fixture levels back on to make sure the stock is properly lined up with the fixture. Then turn them off to make programming easier. Programming a 5-axis machine is just like programming the horizontal mill we used in Class 7. By leaving the WCS set to top, each time we change construction planes, that will trigger A and B axis rotational moves to orient the part differently in the machine. 5 of our construction planes are already defined on this side of the part: the top, front, right, back, and left sides. We'll need to define the four 45-degree planes around the part, as well as the plane for the slot in the top. Open the View Manager and set the construction and tool planes to front. From the Planes menu, select Rotate Planes. Enter -45 in the Y box to rotate the view 45 degrees about the Y-axis in the front view. Click OK and name the view something that makes sense. I'll name it Face Between Front and Right. In the horizontal machine, we could name it something simpler, like B45, but since we have two rotational axes in play, things may get confusing with that convention. Select Planes, rotate Planes again, and enter -90 degrees in the Y-axis box, and name the new view Face Between Right and Back. We can just rotate the planes 90 degrees to get the, we can rotate the planes 90 degrees twice more to get the other two views. -90, and then name the new view. This one will be the face between back and left. And then we'll rotate the planes one more time, -90. And this will be the face between left and front. The last plane to create is for the slot in the top. We'll go ahead and create it by selecting Geometry. Open the View Manager and click the Geometry button to create a new view using Geometry. When creating planes by geometry, it's important to visualize how the part will be cut in the machine. The slot will have to be cut front to back along the Y-axis, since we'll achieve this plane by tilting the trunnion instead of rotating the rotating table, as we can see in this picture. There's a close-up of what's going on there. Select one of the short lines to define the x-axis and one of the longer lines to define the y-axis. Name the new view Slot Between Top and Back. Click OK, and then click the Reset All button to move the plane origin back to the Mastercam world origin. Working with so many different planes can become confusing in a hurry. In this case, the G view can be a great asset. With the WCS set to top, the G view, or how we're looking at the part, will always default to the top WCS. Therefore, if we click Isometric View, we'll be looking at the part's top, right, and front sides, no matter how the construction and tool planes are oriented. Now that our construction planes have been created, we can machine the different sides of the part. The sequence of machining is up to the programmer. In general, it's faster to spin the part around than switch tools, so it's useful to carry out as many operations on different sides of the part as possible before switching tools. I've already programmed almost the entire part in another file. But there is one feature on the part that requires a new tool to be created, and that is the 1.035 diameter threaded hole called out in the drawing. Since there isn't a readily available tap for this hole, and it would require a very powerful machine to tap it, even if one were available, we'll use a thread mill instead. Mastercam has a number of tools in its library, but it does not have thread mills. We can create the thread mill geometry on another level and use that to create a new tool in Mastercam. We'll base the thread mill geometry off a 5/16 inch diameter, 40 threads per inch tool available from Granger. I've already drawn the geometry in this file, so we can create a new tool from it. When drawing new tool geometry, it's important to draw just 1/2 the profile of the tool and leave it open in the center here. Drawing a line to complete the shape will cause errors in Mastercam. To create a new tool in Mastercam, select Toolpaths, Tool Manager. The lower field shows the tool library we set up in the machine definition. In this case, the generic mil-inch library, while the upper field shows the tools we are using to program this part. Right-click in the upper field and select Create New Tool. The first thing we have to do is define what kind of tool it is. Since there isn't a thread mill category, we'll select Undefined. Next, we'll enter in values for it. And these we can actually get off the Granger page here in the specs section. The diameter of the tool is 235 thousandths. The flute length is 660 thousandths. Overall, the tool is 2.5 inches long. The shank diameter is 250 thousandths. And the tip angle is 180 degrees. We can set the shape of the tool by selecting the Custom Level Radio button and picking the level we created the tool geometry on, in this case, level 10. Hit Enter to see a preview in the window off to the right. Click on the Parameters tab to set the material and some basic feeds and speeds. The material of the tool is titanium coated carbide. Let's set a feed rate of 50 inches a minute, a plunge rate of 25 inches a minute, a retract rate of 50 inches a minute, spindle speed of 5,000 RPM, and number of flutes to 3. Name the tool something distinctive, like 40 TPI thread mill, and click the Save to Library button. We'll save it in the mil-inch library for use in future projects. The minor diameter of the threaded hole has already been cut, so all we need to do is run a thread mill tool to cut the threads. We'll need to create a center point to the circle before creating the toolpath, since the thread mill toolpath will automatically set the diameter to any circular feature we select. Select Create, Point, Position. Set your auto cursor override to Arc Center. Right-click on the Quick Mask Wireframe button and pick the arc defining the top of the threaded hole. Make sure your construction and tool planes are set to top and select Tool Paths, Circle Paths, Thread Mill. Select the point we just created, making sure the point autocursor pops up instead of the arc center autocursor. Hit Escape and click OK. Select the 40 threads per inch thread mill and enter an operation comment. Click on Cut Parameters, set the number of active teeth to 10, thread pitch to 25 thousandths, make sure the ID thread is selected, and enter a major thread diameter of 1.035. Machining direction is up to you, but most programmers go from bottom to top. Click on Linking Parameters. Right-click in the clearance plane box, select Z-coordinate of a point, and pick a point at the top of the part. Add 1.5 inches to set your clearance plane. Enter 4.6 in the feed plane, then right-click in top of thread, select Z-coordinate of a point, and select a point at the top of the part. Set thread depth to absolute. Enter the top of thread value, in this case 4.423, and then subtract 200 thousandths to get the bottom thread depth. So that we just pulled off the drawing here. Which doesn't seem to be responding, but it's specified, there it is, 200 thousandths deep threads on there. Click OK to exit and see the results. The thread mill toolpath moves in the X, Y, and Z directions simultaneously to cut the threads. This is a great toolpath to use if your machine does not support rigid tapping, cutting the threads requires more power than your machine has, or the threaded hole is a unique size and a tap is either unavailable or prohibitively expensive. Thread mills are available as both multi-tooth cutters, like the one we created today, and single-tooth cutters, which can create an almost unlimited number of thread pitches. Now that all the tool paths have been created and verified through Backplot, we can use machine simulation to see what the finished process looks like, and watch for any gouging that may occur before the part is created on the machine itself. So over here we have the position field, and you can see how it's moving the A and B axes around. So the A axis is at 90 degrees right now, which is the trunnion, and then the rotational table is at 45 degrees. Then it switches, now it's at 0 degrees, and so on. Are there any questions?
Hey, Micah, it's Derek. Hey there, can you
Hey,
hear me?
Derek.
Hey, Micah. Hey, nice presentation. Thank you.
Oh, thanks. Welcome.
Yeah, it looks good. Okay, well, now's your chance, guys. Micah has just shown you how to set up and program a part for a 5-axis CNC machining center using specifically a 5-axis trunnion mounted to a 3-axis vertical machine. And now is your chance for questions. So I see we have quite a few people. Everybody stayed in there. So let's see. First one coming in, and bear with me while I just kind of undock this over there. There we go. I just have to expand this out so I can see who I'm talking to. There we go. Okay, so we have a question from George. Where is WCS 0? And WCS 0 will be the original system origin. And I know while Micah was working there, Jay was working in the background. I think Jay will come in a minute, and he'll have something to say there about WCS and work coordinate system. So when you're programming a 5-axis machine in Mastercam, the origin, the Mastercam system origin, which is the main WCS, or work coordinate system, needs to be at the intersection point of the two rotating axes. So you can see there, if Micah, hang in there for just a minute. So the rotational axis where you see the round faceplate there on the trunnion is the B axis. And then, as you can see, the trunnion also swings up and down, swings up to the front, down to the back. That's the A-axis. So the intersection, and I think maybe, Micah, if you can just take your mouse down just below the part, you see that little origin icon there. That is the intersection point on this particular machine. So the thing is, in Mastercam, if you're going to use different 5-axis machines, you would want to move all of your geometry in your Mastercam file to be relative to the origin on that machine. And I know Jay will have a comment on that in a few minutes, and he may want to clarify or improve on my explanation there. As I'm looking at the screen, I'm thinking actually this is a little visual thing there. It looks like we may actually be skewed just a little bit off of that rotational axis here, and I'm not sure what that is. It's probably just something in our setup, but ideally we would want to be right at the center line of rotation.
I
Yeah,
think
the one that
that's-
you're seeing, yeah, your one you're seeing on there is not correct. The part is actually, if you look at it, he did set it up by the center. That's just showing a reference to the machine inside the machine simulation. But his part is actually centered up, it looks like, on the rotary by rotary on that configuration. Or he would have gotten
Yeah,
an
this
off,
center
he would have
point
gotten off
moves
axis.
in the machine simulation.
Yeah, or he would have gotten an off axis.
I see. Yeah, right.
And your explanation was really, really well done.
Well, thanks, Jay. And by the way, everybody, that's Jay Kramer stepping in there, and he's our 5-axis instructor. So I'll take that as a compliment. So why Jay, does that origin move around as we simulate?
It's showing a pivot position relative to the two axes in a lot of cases.
I see. Okay, good.
On that. And of course, different 5-axis machines. This one, like you said, is center of the two rotaries compared to, say, a different types of configures, rotary on rotary or table on, got table on head, tilt. Now things, there's been a lot of conversations lately about that on Mastercam's forum, and talking about the relationship between, you don't have a rotary and rotary. So now what you have, and that things start to come from, is you'll have your one specific point on the table, because the table still uses the X and Y, but the actual head tilts compared to, we have two rotaries here. So when the head goes to rotate on that particular one, on that one, the head, now you have to take in for logic of the rotational gauge point of the head where it rotates from. So there's a rotational gauge length, and then there's the tool gauge length. And those actually are now, at that point, are now being, you got your double stacking gauge lengths, and one of the those gauge lengths get added together inside of, usually set up in your configuration of your post. Your post will have the machine rotational gauge length, and then you'll have a spot where you'll put in the tool gauge length, being from the spindle head, being the back of the tool, to the tip of the tool. So now it knows how to add those two together to create the vector for the tilting of the head angle compared to where the home position of the part is.
Right, so it starts to get pretty complex. So let's sticking with that point then, Jay. If you can handle the post-processing output, so take into account, a different machine configuration where the head is rotating, and you need to calculate for the gauge length of the tool. Is there a standard position where you could locate your origin in Mastercam for the part and then have the post-processor completely handle that output? Or is what are the workarounds for that?
Actually not workarounds, but you are going to have your origin. You'll be able to actually set your origin like you normally want to on the part. So everything, because the post is going to handle the vector lengths and the gauge tilt lengths from that position. So you're not where, like, for example, this particular machine configuration, we have to define in Mastercam where the center of the two, like you said, where the center of the two rotations are, so that the machine can handle the pivots from there. Because everything being your Z origin, your X, your Y are all handled at that intersection on that, and you can just touch your tool off to that position. Where now in the other one, you can actually have your home position anywhere on the part on that machine because it's coming onto the table. And then from there, like I said, it's handled by the gauge length of the tool and a pivot rotational point of the head. I hope that made sense.
It does. For those of us who think about it all the time, if it's your first time in here, right now your head might be spinning. But the 5-axis is definitely a much more complicated animal than your typical 3-axis machining. So let me clarify there, Jay. You're saying will be. Are you referring to changes coming in X7 that will change how this is being done?
No, this is the way I programmed head to table to head configurations for many, many years.
Right.
Where, like I said, these Haas trunnion setups, I think, make life so much easier. So much easier to set up, a lot less complications, and you don't have to have, for example, gauge lengths of the tools before you set up your machine or before you start programming. Because if you don't have that information ahead of time to start programming, of course that causes an issue not having those gauge lengths. So the math can't be done before you post out. So you can't pre-program without those gauge lengths. Here, you don't have to worry about that. I can program this entire part like I say, take what Micah did. He actually programmed it from the rotational points. All they have to do is set up their tools and the origin and everything like that on the machine, and they can actually take his posted code and run. The newer changes that are coming with X7 are not going to change. At this particular point, they're not going to change, and I know of, are not changing any of this logic. Because like I said, there's several different types of machines. And there's, like I said, this is a rotary on rotary. There's, rotary head. There's table head. Those types of configurations. And I'm, sorry, but I am going to kind of sell this point here for a moment. That really, if you want to find out about all those different types of configurations and how some of that logic works, going back to our website, if you go back to Apprentice and look at the 5-axis course with Carlo Pro, his book goes through and breaks all this information down. That's what's so great about his actual course and everything, is that he explains some of what I'm going through and gives you pictures and everything to see how things are rotating around other axes and how those axes work. So if you start to get in there going, this is kind of confusing, Joe, I wish I could have some more, this is really when, taking that course and buying that book would really give you that more of that detail and that information, explaining even how on this one, how to actually take something and find out where the rotational center points on these two rotaries are on this particular type of machine, and how to pick up other machines and stuff. So it's not even the programming side; it's actually how to work and understand the different types of 5-axis and how they work.
Right, that's a great explanation, and thanks for mentioning the additional course. So Carlos' course, as Jay mentioned, and then Jay also teaches a course available on eApprentice where it's the specific step-by-step Mastercam programming, how to do 6 different projects. And I just noticed, looked like Micah's internet had dropped off for a minute there, but it looks like he's back, and Micah is navigating on screen to show you the course that Jay was talking about. So thanks for doing that, Micah.
And a great presentation once again from Micah. Everybody, please give him a hand. I know we can't hear you clap, but in the back of my head, I can hear it somewhere.
Yeah, absolutely fantastic presentation. So excellent. Thanks, guys. Let me keep going. I've got some questions coming in. I think, Mike, if you could bring back the machine simulation, that may help with discussion as we're going on here. So just to follow up on George's initial question, so what George has done follow up, his first question was, where is WCS 0, which in this case is the center of rotation, or the intersection between the center of rotation of those two axes, and then his follow-up was, so probe the bore of table for XY. And yes, that is exactly right. And what we would recommend here, if you had a trunnion that was going to go up on the machine and then you were going to take it on and off, I would recommend look at your trunnion for locating features, and look at your machine tool table. I mean, one option is to bolt down an aluminum subplate. This is something we've done in the past, and put in specific hole patterns for locating and fastening features for vices and a rotary fourth axis, and in this case a rotary fifth axis, so that you can always locate that trunnion back on the machine accurately, because those zeros will never change. So if you can make a nice accurate setup, you can take this trunnion on and off with a minimum of setup time as far as locating these zeros, because that is kind of a time-consuming process. And as Jay mentioned, Carlo's course goes over how to find the zeros for a 5-axis machine. Let's see, I've got another question coming in from Stephen. Why is it important to move the part to Mastercam 0 rather than just move the WCS? And I'm not sure if Jay is still with us, if he can give us a more specific question on this, but I think that WCS is not supported at this point in time, and correct me if I'm wrong, Jay, but putting the WCS on the part when we're working with a 5-axis machine and having that output correctly in your post-processor. So I think maybe the actual better answer to your question there, Stephen, is that the complications come not from Mastercam doing the WCS, it's during the output of the G code where we'll have problems. And so yeah, go ahead, Jay.
I was going to say, you are correct, and you are, I don't want to say incorrect. It actually, it does actually work with the WCS. On newer style posts, there was some, if you're using an older style post, say from version 9 or early X, and then bringing that in, you'll find that the post and stuff doesn't know how to work with that translation being a vector. Because basically what you're doing is when you're doing the WCF, you're translating the origin relative to the original origin, location-wise. But so the post has to be able to take care of that mathematics. A lot of the newer posts, I actually have done 3+2 and some true 5-axis using the WCS on a newer post configuration in X6 in the last couple of months, and works great. But majority of the time, the multi-logic in some machines, some posts won't handle it, so you have to find out from your Mastercam dealer, is my post going to be able to support using the WCS, or do I need to physically translate that part to that location, being the normal default for us for many years, because the post can't handle the relative distance, and it has to work with the actual true origin in space from that particular point.
Okay, great. Thanks for that clarification, Jay. And I believe the machine simulation that Micah is using at the moment is actually based on a Haas trunnion. And I know that Haas Mastercam does come with a standard Haas 5-axis post-processor that and machine definition that I'm under the impression is a pretty good post-processor, except for one minor detail that, well, I shouldn't say minor detail, one major detail. I know I've heard complaints that it doesn't automatically zero return at each rotary retract, but other than that, I've heard that's pretty good machine definition.
I've used it many a time. I've used it on a couple of different ones, and I'll be using that same post for teaching at my college.
Right, and would that particular post processor, the standard Haas 5-axis in Mastercam, would that support WCS?
Yes, that should be in the newer one. It's still, even with these, I still with this particular configuration, because it is one particular pivot point, that I still prefer to move it myself. The one that I'm at my customers here right now and watching the machine that I programmed, their 5-axis is a gantry style with an articulated head, using being able to flip the WCS so I can machine the one part of it, flip it over to another location on the machine, and then use the WCS from there. Works out very well. With this configuration, it's still very easy just to put it in that position so you know where it's coming from. But you could get away with the other.
Right. So another aspect of that question is just personal preference. I mean, if you want to be safe, moving your part geometry to that 0 location is definitely an option. And we all have a good friend who uses a different software platform which actually solves some of these issues, called Complete. And I'm going to try and talk him into doing a presentation at a later date to clarify exactly some of this stuff. So thanks for that, Jay.
Yeah.
And
when we get a chance to, for a moment, hopefully before the end, I'd like to go back into the beginning thought real quickly and pull up. We got the Raptor that we use for that particular machine.
Sure.
And that part that Micah brought in, I'd like to just use a different way of translating everything real quickly. To show you another thought that I'm sure a lot of people don't see, without having to create any extra geometry or anything like that to relocate everything where it needs to be.
Right. Okay. So if you prepare, we'll switch to your screen in a few minutes. You let me know. Okay. Well, let me just knock out a few more questions in case they're related to this, and then we'll jump to that.
Fantastic.
And yeah, Stephen had said thanks, so that answers Stephen's question. Jeremy has a question. Can you change the Z value in top WCS if your part is complex and drawn on Z0, for example, -5 inches, to adjust for the chuck? And I'm not, yeah, so let's try that one more time just to make sure we're getting it right. And I mean, you may have already covered it with that explanation. In fact, Jeremy has come down later on and said, close enough to the answer, thanks. And he's also said, good show. So good job, guys. We've actually answered that one. Let's keep going. This one's coming in from Mark. Can you explain programming on a CNC 5-axis router? The head has a rotary head and programming in 3.2 position. Well, I think really, and that came in about 9 minutes ago, so Jay actually might have already done a pretty good explanation on that, talking about the fact that with a head configuration, you also need to take the gauge length, the tool gauge length, into account as well. And I think that opens up, maybe that's a presentation that we could do real soon, Jay, is maybe just look at maybe a thermwood router or something with a head configuration.
No problem. I've got a machine I've already got a machine for the machine simulation. I've already got the machine built and everything for that, so I can actually pull up that particular thermwood machine and actually go through that. So okay. Let's plan for that.
Okay, well, let's schedule that. And then, Mark, if you want to do a follow-up, but certainly, Mark, you'll be on the mailing list since you're on a webinar here. You'll get an invite to our future ones. And I'll talk with Jay offline, and if we can make that happen, even if it's just really more of just kind of a demo informative thing to really to show the difference, that'd be super valuable. So we'll move with that. Follow up, Mark, if you have a follow-up on that. Let's go down, and Stephen just had a comment. So it's more on the safe side to just move it, to move the geometry to the correct origin. That's a fair comment, Stephen. As Jay said, WCS is supported in a lot of modern post-processors, but I'm sure that a lot of 5-axis guys out there will say that's exactly what they do. They just move the geometry.
You'll find most of us do.
Right, and when Jay is referring to, we've talked about the Haas post processor machine definition that's included with a standard install of Mastercam. But if you have a machine that has a different configuration, you are going to want to contact your reseller, and you'll have to invest a little bit of money. I mean, it could be from a few $100s to a few $1,000s, but certainly having the correct post processor for your machine is a very vital point. It's something you're going to want to do. And you can check on emastercam.com. That's the letter E, mastercam.com. And they have a link up there for getting a quote on a post processor. So let's keep it moving here. Christian has a question, indirect but related to machining question I have is, when will Jay Kramer teach another course at College of the Canyons for 5-axis CNC programming in Mastercam?
Who was this asking the question?
This is Christian Kepler.
Okay, Christian. I'm not positive. I'm hoping just to get something together for February, as we had just gotten this new 5-axis trunnion configuration in. And yes, the plan is this time around for my particular class will be a hands-on, learning how to set up the Haas trunnion machine, how it works, how to put a probe on it, and learn actually set up and cut something with some type of a 5-axis cut on the particular machine. If you keep in contact through eApprentice or through j@eapprentice.net, I'll let you know when that's coming around. Thank you for the side note there.
Excellent. And Christian, I know, is enrolled in at least one of our courses. He may already be in your 5-axis class. I'm not sure. And then Mark also said, I'm in for this college class. So Mark, sounds like Mark's down in the LA area as well. So as long as Jay's plugging College of the Canyons down there in the northern Los Angeles area, now introducing actual 5-axis CNC programming and machining, which is certainly vital to the reshoring that's happening in manufacturing as it's coming back, and these multi-axis machines are definitely driving it. I'll go ahead and give a plug to De Anza College up here in Northern California. We're in the San Francisco Bay Area, and we have also just installed a mill turn and a Swiss type machining center, and we will have a 5-axis DMG machine, which is a Morriseki machine, on the floor here within several weeks. So good to see that the colleges are definitely investing in the technology that you guys need to stay on top of things.
Now, Derek, real quickly, let's jump back to your apprentice. I think we had kind of a small conversation at one time of, I was talking about doing this class at the college, but we were also talking about maybe putting something together on our site, being the apprentice, where taking a lot of what I'm going to do in that particular class and building as a course online. You don't get to touch the machine, but taking video of how literally hands-on how I would do that at the machine, along with samples and along with other videos showing how to program and how to set everything up and do that kind of stuff, offering kind of like a machine, a true machine, seeing the true machine and how it would cut, and explaining that information along with how to program that.
Excellent. We will definitely do that. So you and I will talk about it offline, and I'm certainly happy to go down there 3 or 4 days a week to get it put together, Jay. So let's work on that offline, and let's shoot for early in the new year for a full-on 5-axis course.
I agree.
Okay. So Christian, Christian just following up with comments. Yeah, he buys into what you're saying, and then he's mentioning he also saw the Haas trunnion there at the aerospace company where he works. Let's keep this going. Brian's had his hand up for a while, so let's jump to Brian, see if his mic is turned on. Hey Brian, can you hear me?
Yes.
Hey Brian, how are you?
All right, ready to rock and roll.
Good, good. How can we help you?
How can I? Well, I'm just interested in the course. We've got a DMG here, and I'm open to, not just a full 5, but the 3+2 does look pretty promising for some areas.
Sure, absolutely. And when you say here, where are you located?
Massachusetts. We're in Newburyport, Massachusetts.
Okay. And what company? Is that something you can say out loud, or?
Yes, I can. Our wood machine.
Yeah.
Our wood machine, mill spec. We do a lot of mill spec. We've got, let me see, 5 seats of mill 3. We got a couple seats of lathe, seat of wire.
Okay.
So you guys, it's safe to say that you like Mastercam. Ryan, you still there?
Well, I'm having trouble understanding you. What'd you say?
I was saying that, so I would assume that it's safe to say that you like Mastercam.
Oh, yes.
Going through the thought real quickly as you came in and talked about, interesting thoughts about the 3+2, you're going to find a lot of shops, a lot of 5-axis stuff that's actually done. Majority of both 5-axis stuff, still to this day, is usually 3+2, locking in the 2 axes and cutting. It matters on the particular types of parts where you truthfully get into swarf and curve 5-axis and flow line 5-axis and that kind of stuff. But a lot of the parts, but still, like I said, looking at this particular part that Micah did, definitely a 3+2 part. There's nothing that really needs to be done with a 5-axis because everything can be taken to that axis and taken care of. But the 5-axis makes it easier instead of doing, like Micah said in the first point, is so many setups. When you look at something like this, you start looking, okay, you're 6 sides to this. So a 6-sided block, that means I got to do 6 different setups to be able to do it. And every time we have to handle a part, right, there's more chance for error. Now, in this case, he's eliminated by, like you said, he's showing the part here, and by eliminating several of those operations being, the dovetail's one, but it's really not considered an actual part machine configuration. You're prepping the block in this case, like squaring it up. It's the other 2 operations. Now you've taken care of 5 sides of the part, all in one day, and you know that from point to point in every location and everything like that, that the part is going to be true to itself. And then all you have is one more configuration to set up compared to a lot of others. And if there's also too is that you find things like this, like when I do a lot of valve bodies and stuff, there's compound angle holes and stuff. So now these 2 also can be handled compared to I've done them on 5-axis and I've done them on a horizontal. The horizontal still, once again, has a limitation of how many rotations and what angles I can get, where usually I can't get a compound angle too well. And compared to, I can actually get a true vector off the 5-axis to take care of those internal details.
Yeah, that's where, a lot of times that's why we're using the 5, is just because of less setups, inherent and accurate, and although we are starting to do some true 5, and the post is obviously ready for it.
Yes, it's an important thing, and you've got a really nice machine there, by the way. That's a higher end machine right there.
Yes, we just picked that up. We had a DMU, and we picked up a GMG a few months ago. Love it.
Fantastic.
Right. Well, good stuff, Brian. Thank you for the comment there. Are you already programming the 5-axis machine?
Oh, yes.
Yeah.
Oh, yes.
Yeah. Good.
Hey,
Well,
you're letting something like lack of knowledge stop me.
yeah. Well, yeah.
3+2, you can look at the code, and, it's nothing.
Sure. You're rotating around. I agree with you. Once you've got the equipment, programming this part is actually a lot easier than programming it even just for a 3-axis machine, just because you don't have to think about the other setups. You just start applying tool paths.
Yes.
And if you're, for those of you out there who have to worry about the budget and the profit and loss, the big benefit for me is the reduction in work in process inventory. So imagine you're just, you've got one piece of material and you're applying labor, you're applying value to all the different sides of that piece of material, pull it off, finish the last operation, and ship it to the customer. As opposed to having a cart full of material that you then start to process through on a vertical machine, one operation at a time. This part, if you were running 100 parts, one operation at a time on a vertical mill. It might be a week and a half from now before you actually get your first finished part that you can sell.
Mm-hmm.
So work in process inventory is a big deal.
Yeah, yeah.
Well, great. Glad to have you, Brian. We appreciate it. And if you're interested in any of our courses at eApprentice, of course, please check them out, or any of the other people that you work with. If you've got some apprentices there, please check us out. We start with at the very beginning, and we work right up through the advanced stuff.
Yeah, yeah. Yeah, I've looked at you guys. Mastercam's offered pieces of their training, and I've seen every now and then you offer one. I just say you have to keep your eyes on the blog mastercam.com. Otherwise, it's a short notice time. I missed the last one.
Yes.
3 weeks ago.
Well, we hold these pretty much every week. We do sometimes miss a week. We'll miss the next 2 weeks just through the holidays, but we'll be back early January. I don't have my calendar in front of me, but I want to say it's around maybe January 9th. We usually hold them on a Wednesday. It's lunchtime for us out here on the West Coast. It's a little later for you back east, probably 3 p.m. And 4 p.m. now, yes, because we've been going for an hour. And as we build this company, we do CNC training and process development. And as the company grows, we plan to add just private office hours where you can even schedule time with Jay or Mike, who's not with us today, or Micah or myself or Carlo. And we're up to 6 instructors now, and we're growing. So the time will come where we'll be there for you anytime you need it. So just keep tuned into this site, eapprentice.net, and stay tuned, and you will get invites now. Now, I agree with you. Sometimes the invites do come out late, just because we're still trying to figure out what we're going to work on for this week. We're pretty busy around here. But we are aware that a schedule would be much more user-friendly for you guys out there, so we're definitely working on it.
Well, if I know to check every Tuesday, I don't know if I can go to the eApprentice itself has the schedule? Is that right?
eApprentice.net, and the schedule is... We've got some crashing going on there in the background,
Sorry.
But the schedule is not yet posted on eApprentice. We're about to switch over the next few weeks to a new revision of the website, and that is coming with the new revision. But definitely stay tuned to eApprentice and watch your email for those invites.
Yeah. All right.
All right. Thanks for checking in, Brian. We appreciate it.
Yeah.
Thanks. Okay, Jay, let's see. Comment from Ben. Thanks, very good show. Well, we're at our hard stop of an hour, and we're 3 minutes over it. So, Jay, I'm going to switch to your screen really quick, and let's see if we can do a demo of the Raptor and the translating before we call it a day.
Okay.
Are you ready for me to change over?
I'm ready for you to change over.
Okay.
Hopefully I can keep some of the background noise down.
Yeah, well, I hear you're making parts back there, and that's the most important thing.
There's machines running in the background.
Exactly.
Can you see my Mastercam at this particular time?
Now I can. I can see your Mastercam, and if you click just below your Show My Screen with a drop-down arrow, that'll just kind of hide all your icons and stuff in the back in case you have any confidential information up there on your screen.
Show Screen 1. How is that?
Now I'm seeing just the background image. Looks like a beautiful waterfall. Well, don't worry about it, Jay. If you go ahead and just show the Mastercam.
I mean, there's nothing I'm really worried about that you can see in the background on that. Can you see at least the Mastercam now?
Yep, we can see your screen. In fact, if you just maximize your screen, that'll probably do it.
How's that?
Perfect.
Okay. All right. I'm going to go ahead and set this for isometric real quick. I'm going to go ahead and bring in the Raptor configuration on that. So in that case, I have the Raptor right here. So looking at the same configuration thought, you can see that it's a distance away on that. Before he did a export and translate kind of configuration, we also have another tool inside Mastercam that predicts it, because this is just a straight down conversion down to this point. So I'm going to actually, I've added it to my right click, but I'm going to show you where it is here on the top of the bar. There's one that says Export Move to Origin. So in this case, I'm going to go ahead and select that. Always look at your prompt, select the point to be translated from. So I'm going to look for the center of this solid. Right there you can see that particular point where I want it, and I'll select. And automatically translate that. If I was in X and Y in a different location, it would still translate it in 3D to that position. So that took care of getting our fixture down where we wanted it in the first place on that without having to actually export, translate, give it a value, type it down. We actually had, using a specific point, in this case being the intersection, this actual centerpiece you're seeing here that I'm highlighting is the plug that goes on that particular trunnion on the 160 TR trunnion that you're seeing in our videos and stuff. This is specifically from that manufacturer of Raptor on that. So now I've got that set. Now what I'm going to do is I'm going to bring in the part file too. So using that file merge for pattern, and let's see here, I had that, the assignment, but then I had the assignment, just the part. There we go, because he had all the toolpaths and everything on it. Okay, so in their case, there's the part. And we can see that it's just one simple solid when I select that. So what I'm going to do is I'm going to actually translate this down to the center line of here. But I'm not going to actually create any more, I'm not going to create any more geometry. I'm going to use the existing geometry we have. So I've added to my right click one of the tools I like to use. You'll notice about 1, 2, 3, 4, 5, 6, 7th one down is the X-Form Dynamic. I'm sorry, Dynamic X-Form. I did it backwards. So I'm going to use this option. This is going to be a way of actually translating the particular part to where I want it in space without actually touching, without actually moving the fixture, but only the part. So I'm going to say Dynamic X-Form. It says select the entities to move or copy. In this case, I'm going to select this one. I've got it set right now. I'm going to say OK. It's coming up with the gnomon, asking me to go ahead and set up so we can actually use the point from one position where we want to transform to the other position. So right now, I'm going to go ahead and select the bottom of this intersection here being a midpoint. And we can see in this case, our Z is actually selected toward the top. It's the way I wanted it in this case. So now what I want to do, but I want to get this set up in the midpoint like we had done before. Since we have a solid, I can do that. I'm going to use, right now we're set for manipulate geometry. I don't want to manipulate geometry, I want to manipulate the gnomon. So going over here to manipulate axis. So now I'm going to grab the linear along the y-axis and actually tag to the midpoint of this particular edge right here on the solid. So now you can see is that I actually have this in the center of that part. So now what I'm going to do from there is I need to get that particular point down here. So what I'm going to do in this case is now we've got it set for manipulate axis. I don't want to manipulate the axis because I've got it where I want it. Now I'm going to go back into here and say manipulate geometry in that case. So select that. Now I can go and grab that gnomon again, being the axis position point, being the intersection, and I can see as I can physically move the part. So what I'm going to do is I'm going to manipulate that part and bring it down to the midpoint of this particular line here. I do need it in the midpoint of here. And since this geometry happens to have a midline there, I'll be able to use that. But now if I actually start grabbing this and taking that part along the y-axis, I can actually go over and hit M for midpoint if I want, the midpoint along here, along that y line right there. And you can see that I've now manipulated the part with no extra geometry, nothing else created, using this option. So once I find that location I want, I'll go ahead and green check. And now, clear screen, clear colors, you can see our part sits exactly where we need it without any extra geometry created. In this case, using that solid using the dynamic X-Form to translate that. I hope you found that helpful at this particular point, and find that the X-Form Translate gives you multiple options besides physically actually transforming the whole part in space somewhere when you bring it in using the dynamic gnomon. But it also gives you an option to bring parts in and reconfigure them to existing. I do a lot of stuff like that where I bring in stuff from, I'll go to Mastercam and grab bolts and things like that, bring the bolt in, let it do the file merge, let it put it in space in the middle of my part, and then using this particular tool, just like I did, grab it and place it in the locations. For example, might be a bolt that goes in each one of these. So I can make one, and then I can export and rotate that around, in that case, using the, after that, but using the dynamic X-form to actually relocate the part physically, compare it while you have other stuff inside of your file.
Yeah, that's yeah. Thank you, Jay. That's a fantastic demonstration. I mean, even just dynamic transform itself might be worth at least a short class. There's a lot going on there. So thanks, Jay. I really appreciate you jumping in there and showing us that. I want to also say thank you to Micah for just another fantastic presentation. And we're at about we're 11 minutes over right now, and I've already been yelled at because a lot of the guys on the West Coast want their employees to get back to work after lunch. So we're going to have to jump off here, folks. I'd like to, and several people have come in and said thank you for the show and Merry Christmas. So I'm not going to read through them today, but we do appreciate your comments. We do appreciate your time. We realize you guys are investing time to be here with us, and we do appreciate it. So thank you to the presenters. Thank you to the audience for being there, and I want to wish everybody happy holidays. Hopefully you get a little bit of time off with your families and get some time to enjoy yourselves for the holiday, and we'll see you back here in a couple of weeks. Watch your email for the invite. So thank you, everybody. We really appreciate it. Bye now.